I hope you're all well, keeping safe and well. Given the circumstances, I'm sure you're dying to get into doing some perimeter area and volume, so we'll get into this. I know prior to the shutdown, for the vehicle maintenance guys anyway, on the Monday we had started doing Pythagoras and Trig, and that was going to be my plan, but since obviously we're not there, I'm going to do outcome 2. So outcome 2 should give you guys enough topics within the course to allow me to pass you if you complete a wee assignment at the end of it. We're still trying to figure out between Stevie Fleming for the Fab and Well guys and Andy Walker for the vehicle maintenance guys, who are your CQLs, we're still kind of debating what's the best course of action, because a lot of it we can decide certain things in-house, but a lot of our direction comes from the SQA, in terms of making sure you guys meet certain learning outcomes from within each course. So I'll put this up now so it gives you a head start, but this is a good outcome to do because a lot of it is very accessible. It's not massively difficult. So it's focusing on perimeter and circumference for circles, volume of cuboids and cylinders, so that you're essentially only dealing with two 3D shapes. The cuboids and the cylinders are your 3D shapes, and we'll look at compound shapes for 2D area and perimeter. Okay, so I'll do one long video covering all the notes. I'll put blank notes online. Your best bet, I think, if you're going to sit and go through this, is to print if you can, if you've got access to that in the house. I know a lot of you won't, okay? Go through it yourself, following the video. I'll put up a full worked notes if you like, and I'll put up extra questions, and I'll do a work solution of the practice assessments that are the back of your that craft booklet, like we did for the previous assessments where we sat and we worked through them. Okay, so in terms of the equations you need to know, I know it looks like a lot here, but you'll see a lot of them repeat themselves. If you were doing this in class, the only equation you're given is this one here. Okay, but obviously if you're sitting working at home, you've got this as a reference, so you can look back at it. Okay, so my first two, that's your symbol for area. Area of a cube or cuboid is length L times B. Area of a circle is pi r squared. Circumference, which is just denoted by C, is pi d. And we've seen pi before. Pi is just a button on your calculator. In number terms, it's equal to 3.14159, like it goes on forever, but all you're interested in, use the button in your calculator, okay? V, volume of a cuboid, length times breadth times h, L times B times h. Volume of a cylinder is pi r squared h, so pi times the radius squared. So r stands for radius, which we'll get to when we come to circles. H is just height. Don't worry that that's a capital there and that's just a small h, right? It means the same thing. This last one, curved surface area, CSA. There's not really a dictionary definition. I call it CSA. 2 pi r h. Okay, so those are the equations we'll be using. So if you're ever unsure, flick back to this page and you'll be able to find the equation you're looking for. Okay, so first of all, fairly easy, perimeter and area, or area and perimeter. Okay, so we've got a rectangle here. In general terms, as you look at it on the page, the horizontal is the length, and this one here, the vertical, is the breadth. It really doesn't matter. Don't get yourselves worked up about if you do them in the wrong order. Okay, because see, if you in your calculator, if you do 4 times 12 or 12 times 4, you get the same answer anyway. So don't worry about doing it in a specific order. Okay, when it comes to doing circles, there is a specific order you need to do certain things, or the radius is a certain diameter, a certain number. You can't just pick and choose, but here you can. Okay, so we've got area is L times B. Remember, just show you working. I know it's dead simple. 12 times 4, which gives you 48 centimeters, and it's area. So we use the cm to centimeters squared. Okay, you saw loads of units being used in the previous outcome. Your units for area are length, so centimeters, millimeters, meters squared. If it's just length, which is what we're just about to do, is perimeter. So perimeter. Now the perimeter of any shape is just the length around the outside. So if you were to measure around the outside, you would just add up all these lengths. Okay. So the only two I'm giving you so far are 4 and 12. So add them together. Because it's a rectangle, this length here matches this length here. So that's 4 as well. And same goes from here, opposite, we've got 12. So add them all up, gives you 32. And all we're doing here is centimetres for our units because it's just a length, it's not an area. So our 3 sets of units, if you like, are length is like millimetres, centimetres, meters, area, millimetres squared, centimetres squared, meters squared or kilometres squared, and volume in length terms would be millimetres cubed, centimetres cubed, and meters cubed. For volume you can have things like millilitres and litres, but we are not interested in them. Okay, all we're interested in is the length units. So okay, so that's you for your first question, if you like, perimeter and area of a rectangle. Okay, so this next few one, dead easy. I'm not going to go through it in the video, but when I upload the notes, the fully completed notes, I'll make sure that's done. Okay, so give that one a wee go yourselves and just marry it up with what I did there. Okay, so perimeter and area. Okay, next one, compound shapes. So all compound shapes is larger shapes made up of smaller shapes. Okay, so there's essentially 3 ways you could look at doing this. You're going to need to break it up into 2 smaller rectangles first. Okay, so you could either come down this way, break that up. You could cut it that way and have that rectangle, that rectangle. You could, I know some people might prefer to do it this way, make it a big massive rectangle, then subtract this area. All 3 methods get you the answer. Okay, I think the easiest way to go about it is just to split it up. I'll go this way. Okay, doesn't really matter whether you go the other way or not. Okay, so I'll call this 1, this 2, and I'm doing my areas. So all it is 2 rectangles, so it's not that we're doing anything massively different, there's just one last step you need to add in. So area of the first rectangle, length times breadth. Don't worry about the order because 8 times 16 and 16 times 8 the same thing. 16 times 8 gives you 128. I wouldn't worry too much about the units there. Yeah, don't worry about the units there because there's one final step we'll need to do, and that's adding them together. So I'm not fussed about having my units here. My area of 2, still going to be L times B because it's still a rectangle. Okay, now if I look at 2, that 20 is not the length of this. I want this length here. 20 is the length of that, so it's too big. Alright, so I need to use this to help me. 20 minus my 8 gives me 12. So my area of my second rectangle, the smaller one, 12 times 6, which gives you 72. Right, so you have picked up marks doing this, but to finish it off, my total area, and I would always write this, is you're going to write A1 plus A2. Doing that, this line here is important because it shows that you know to add 2 areas together, so it's a valid strategy to get the final answer. What you'll tend to find is people get to this stage and then they'll go this times this, so multiply 2 numbers together. All you're doing is adding them. So 128 plus 72 gives you 200, and this is where I'm going to put my units in, centimetres squared, because that's my final line of work and my final answer is that. Okay, not overly fussed about having my units in up here. You can put them in if you want, it doesn't really make a difference, but you need to get your units in at the very last step. Okay, so I've uploaded a Word document onto Moodle, and on that Word document there's linked to a website called Corbett Maths, which is a really good resource. Loads of different worksheets, so I've put areas of compound shapes. If you click that link, there's loads of different wee shapes like this. I would give them a wee go. Okay, so perimeter of the shape below, so it's just the same shape, but the only difference is I'm doing perimeter. So perimeter, we said, was the length around it, so the length is that plus that plus that plus this plus this plus this. Okay, so perimeter I'm going to use all my lengths I've got thus far. So 16 plus 20 plus 6 plus 8. There's 2 lengths I'm missing. I need to get this and this. And from what we said before, that's 12. This vertical one here, I need to figure out. And again, if it's the same concept, if I flip it to the side, that's got to be 10. Because this is from top to bottom there is 16. I know this in here is 6, so that's got to be 10. So plus 10, and then just fire it all in. 16 plus 20 plus 6 plus 8 plus 12 plus 10. So that's 72. 72, and all my units for this for perimeter are just centimeters, because all perimeter is just a length. Okay, so in terms of 2D shapes, the other thing we need to look at is circle. Okay, now circle, the 2 equations for circle are C equals pi d. So C is the circumference. The circumference is the length around a circle. The circumference is just the perimeter of a circle. It's just given a special name. Okay. The other one is area of a circle is pi r squared. So there's that wee pi symbol appearing. The only 2 things we need to have a think about is this d and this r. In circle terms, d is diameter. R is radius, and you see them capital D, small r. That's just how they appear in equations. Okay, in terms of what that means in a circle, if you were to try and measure a circle from the widest point to the widest point, okay, so across the middle, I know if you were doing that, if you were to stand a Smarties tube up or a Pringles tube and you were to try and measure how wide it was, you know, you'd line your ruler up as best you could to try and get it going through the middle. That length is known as the diameter. Right, so the diameter is the longest length. It's like the width of a circle. The other one, the radius, is from the centre out to any point. It doesn't matter whether it's here, whether it comes up here, whether it comes down the way. From the middle out to the circumference is your radius. And there's a special relationship between the 2 of them. Right, so I'll do it as like a wee equation, right, and then we'll have a look at some numbers here. The diameter is 2 times the radius, or the radius is the half of the diameter. Okay, so if I was to do a wee sketch, in fact, I'll do my wee shape editor, right? So if I was to draw a wee circle here, right? Just do it as white, okay? So if I was, and you'll notice we need to know about both of these dimensions. The reason why we need to know about both these dimensions is because each equation wants one of them. So if you're given the diameter and you're calculating the circumference, you would just plug the number straight in there. If you were given the radius, for instance, so if I go, right, I say the radius there is 10. So if you're given a wee diagram, it looks like this, and you've got a line from the centre out, and it's only half of it, it's the radius. Now, if I was to want the diameter, if I know the radius, all I need to do is double it to get the diameter. So if the radius is 10, it means the diameter's got to be 20. Okay? So I'll rub that out. If I go the other way, if I say, it's just a wee bit bigger. Okay, so let's say for instance I drew this and said that was 45 millimeters. Okay, if I know the diameter is 45 millimeters, because if we look at it, it's like the width, it's like the longest length across the circle, so that's the diameter. The radius is half of that, which should be 22.5. Okay, so that's the relationship between the 2, and you will need to use both. Sometimes you need to use the radius in the equation, and the diagram will give you the diameter. Vice versa, sometimes you need to use the diameter to calculate the circumference, and the diagram will give you the radius. So you need to be able to use both. Okay, so let's have a look. So Calculate the circumference of the circle shown below. So, my circumference equation, C equals pi d. Alright, so pi is just a button in my calculator, I don't need to worry about that. Now, d, remember, stands for diameter. Now look at your diagram. I've got my longest length, it is the width, it is the diameter, so all you would do is do that, pi times 12. So shift pi times 12, remember, if your calculator gives you 12 pi, press the SD button, 37, so it's going to give me 37.699. You're going to get loads of decimal places. I would just, and might not have said it in my notes, right, I would just round things to one decimal place unless it's otherwise stated. Okay, so rounding that to one decimal place gives you 37.7 centimeters. Remember, the circumference is just a name for, is a special name for the perimeter of a circle, so the length around the outside. So it's just centimeters. Okay, it's just a length, it's not an area. Okay, so calculate the circumference of the circle shown below. So again, C equals pi d. Pi times, this time I've only got half the width, half the long length, so that's a radius. Now I want that, so to do that I double it because it's 10 there, it's 10 there, so it's going to be 20. So pi times 20, shift pi times 20, 62.8 centimeters. Okay, so there's two examples then, basic examples. So there's when you're given the diameter and you need to use the diameter, so you don't need to worry about halving this number or doubling it, you just use that number. Here I'm given the radius, if I rub this out, I'm given the radius here, alright, and I want to use the diameter, so I need to do something with this number first. Okay, so I double it, you don't half it again. If you were to half it again, you would get 5, which is that length. Okay, so you want to always use, when you're dealing with circumference, you want to use the long length. Okay. Next. Okay, calculate the perimeter of the shape below. So remember, two things. It's now saying perimeter, even though we've got a circle or a semicircle. Okay, so the perimeter is this plus this. So first things first, this length here is easy, that's just 15. Okay, so that's easy. The tricky bit is going to be the circumference. So if I quickly sketch in here, if I was to ask you the circumference of that whole circle there, C is pi d, pi times, now if you picture that whole circle there, the long length from there to there is 15, which is the diameter. So pi times 15 gives you 47.1 meters. Okay, so that's giving me the total length. Now that's a semicircle, it's exactly half of a circle. So I'm going to C, and I'll go SS, semicircle, is 47.1 divided by 2, because it's half of it. Divide that by 2. So 47.1 divided by 2, 23.55. Okay. Right, so that's, if I go back to my original diagram now. Okay. So that length I've calculated is this. So last step, just to calculate the perimeter. Perimeter is going to be 15 plus 23 point, I'll just round that to one decimal place, 0.6. So add that together is going to give you 38.6 meters. Because remember, it's perimeter is just a length, so that's a good wee example of combining circles and perimeters. Okay, so that's not just as simple as plugging a number in. There's a couple of elements to that. We're halving it here because it's a semicircle. We're halving it here because it's a semicircle. Alright, and then we're doing this last bit because it's asked for the perimeter. So the perimeter is just the curved length plus the flat length. Okay. So area now of a circle, and again I'll put on the Word document I've uploaded with the links, I'll put a worksheet on for circle. I'm not saying you have to sit and do all these circle questions, but if you're a bit unsure about doing diameters and radiuses, then it's worth having a look at. So, area of a circle is pi r squared. That's your general equation. So no matter what you're given here, a circle and its area, you're going to need to use pi r squared. Pi, button in your calculator. The radius, this is what the r stands for. Now if I look at my diagram, I have half of the width. So I've got from the centre out, it's a radius, so all I'm doing is pi times 10 squared. Alright, and you're familiar with putting that style of question into your calculators. You'll have the button on the scientific ones is a wee x squared. The button that sometimes is in your phone is the wee like up arrow. There's one depending on what. You'll have that. You might have a button that looks like it's got that wee with a wee 2 next to it. You square it. Okay. Once you plug that in your calculator, you get 314.2. 314.2, and it's area this time, so I need to put my meters squared. Okay. So still using radiuses and diameters and stuff. And the only thing that's really changing is I've got my units as meters squared. Okay. Have a go doing this next one yourself. Again, I'll fill it all in when it comes to things, but just watch because you've not given the radius this time. Okay. And again, have a wee go at this yourself. Alright. Based on if you can do the perimeter one, that last example that I did when it was perimeter, have a go at doing this. Okay, and again, when I upload the notes, I'll fill this all in, but I would suggest having a go at doing this one yourself. Now, area of compound shapes. So we saw previously that compound shapes are shapes that are made up of smaller shapes. Here, last time we split up the shape ourselves. It was 2 rectangles. Here I've got a rectangle and I've got a semicircle on top. Okay, so have I got 2 of them? Yeah, okay. So I'll go through this first one and you guys, I'll leave that one blank for you guys to have a go. Right, so again, we've split it up for you here, so we've given you the wee cut bit here. It doesn't matter, I'm in the habit of calling things like area 1 and area 2, so I'll do that. Area 1 is a rectangle, nothing to do with pi, no radiuses, no diameters. L times B. 16 times 20, which gives me 320. And again, I'm not fussed about my units, I'll put it in anyway, but the most important bit is my units at the very, very end. Okay, I'll move that over just a wee touch so I can give myself a bit more room for this bit. Okay. Right. Area of 2. What? Area of 2. So, A2 is a semicircle. Now the area of any regular circle is pi r squared. And I'm just going to stick, because it's a semicircle, remember a semicircle is exactly half of a circle. I'm going to stick in, I've divided it by 2. Okay, it just does it in one line. You can do it separately, you're still going to get the marks. As long as you half it at one stage, you will get the marks. Pi is the button in your calculator. All I need to do now is figure out what number I'm squaring. So let's have a look. So I want to know what this length is. So if I do it here, I want to know what this length is, or specifically I want to know what that is, but I'm going to kind of do this in 2 stages. So because this bottom shape's a rectangle, see if you were to cut at any stage across there, it's going to be 16. So that across the top there is 16 as well. So that's the diameter of this big circle, right? That's the diameter. So half of the diameter is the radius, so the radius is going to be 8 because it's half of 16. So put that in there, pi times 8 squared divided by 2. So I'm just going to put that in one line in my calculator, shift pi times 8, hit my wee squared button, divide it by 2, gives me 100.5. So the area of that is 100.5. My last wee bit, remember I said always show this wee bit, this is dead important, because it shows you, you know that the correct strategy is to add them together. So that's going to give you 420.5 meters squared. And what I'll do, actually, see when I upload it, I don't think I put it in, but for this one and the next one, I'll do an example when I put on my notes of calculate the perimeter also. Okay, so maybe give that a wee go as well, and do the same for the next one. So the next one, I'll add in the wee caveat area and perimeter. Okay, so just watch how this bit has been cut away from the main bit. Okay, so have a wee think about what that means in terms of what you're going to do. Okay, we've got a semicircle, we've got a rectangle, and it's been cut away, it's been taken away. There's a wee hint. Okay, so I'll put that up in the full completed notes. Okay, so what you might want to do here is pause here, stop here. I'm going to continue this video, so pause here, maybe have a wee recap, maybe do some questions on area of the compound shapes and the circle ones from the questions that I've put up. Okay, before I go on to the next wee bit. So I'll continue this video, but I would suggest maybe pause here and have a wee look at what I've done, because I would say there's more in this one than there is going forward. Alright, next one I would say is fairly straightforward. The next wee bit is we're going to look at is the cuboid. So now we're moving on to 3D shapes. Okay, so volume of a cuboid, if you go back to the very start, your equation list, V cuboid was L times B times H. Now, don't get us again, like the rectangles, because you're multiplying numbers together, technically I think as you look at it, that's your length, that's your breadth, that's your height. So like across the way is length, into the page is breadth, and up the way is height. But see, when you're putting your numbers in, you don't get deducted if you were to put it in as 10 times 5 times 15. Okay, it doesn't matter because you're multiplying numbers together. So 15 times 10 times 5, easy. Multiplying your 3 dimensions together. 15 times 10 times 5, 750. We're dealing with volume this time, so just watch your units, centimeters cubed, cubic units. It's not asking you to do the other units of volume that you do get are litres, milliliters, that sort of thing. We're not bothered about that. Okay, all we're bothered about is the length units, so centimeters, meters, and millimeters cubed this time. That's it. L times B times H. Plug your numbers in. State your equation, plug your numbers in, get your answer for your units. That's it. Volume of a cuboid is easy. Just remember that equation. Okay. So I've put in some questions there to do with volume and surface area. Okay. Surface area of a cuboid it's okay. It's a wee bit tricky. You just need to remember one thing. So as we look at it, remember, right? If I do a wee doodle on this, it's a 3D shape, so there exists. It's just not shown. I was to kind of fill this in best I can. It's alright. There you go. So you imagine that there's a bit behind this. If you were to imagine breaking down a shoebox, for instance, you'll have the front, as you look at it, right, the top and the bottom are the same. The front and the back are the same, and at either end they're the same. So this end and that end and there are the same. Top and bottom, they're both the same, and the front and then the back are all the same. Okay. All we're going to do is use our area questions before, right, and calculate the surface area. So how much cardboard, for instance, would be required to make this box if it was a 15 by 10 by 5 box. Okay, there's no right or wrong working for this, but what I've found, it tends to, if you write front, top, side, and we'll just do it as 3 separate ones and we'll add it up at the end. Okay, so if I look at the front, right, so I'm looking at it, I'm going to call this the front, this the top, and the side. Okay, so looking at it from the front is 15 by this height. Now the height of the thing is 5, so it's 15 by 5. I don't know why this pen's doing this. 15 by 5. Okay, the top, if I look down on it, is, I'll get rid of this actually, just so I can kind of talk you through this. The top is this length by this length. So even though that, if we look down on it, so this is 15 and this is 10. So it'll be 15 times 10. And looking at it for the side's fairly straightforward, is this by this, so it's 10 by 5. 10 by 5. So those are basically a kind of wee trick to this, right? Is make sure you multiply each number by the other number once. 15 by 5, 15 by 10, 10 by 5. That ensures you get all three sides in. One other thing we want to add in, I just do it in here purely. You can do it at the very end if you want, but I think doing it here. The front and the back are both the same, so I'm going to multiply this by 2. The top and the bottom are both the same, times by 2. Both the sides are the same, multiply it by 2. Alright, and then we're just going to fire that in our calculator and then add them up at the end. And if you set it up like that, it shows that you know exactly what you're doing. You've got the kind of marks here are, you get your dimensions in, which are these, the 15 times 5, 15 times 10, 10 times 5. We're doubling it all because we've got front and back are the same, two sides the same, top and bottom the same, and then we're going to add it up. Okay, so you kind of set it up like this. Easy layout, easy to mark, and easy for you guys to follow. 15 times 5 times 2 is 150. 15 times 10 times 2 is 300. And then 10 times 5 times 2 is 100. So adding that up, you do it in your head if you want, so that's 400, so 550. 550, and then it's centimetres squared, because it's an area, it's a surface area of a 3D shape. So it's 2D within 3D if you like. Okay. Right, I'll do the bit back ones of this for you and you can fill it in yourself. So front, top, sides. So just watch where they put the dimensions. Okay, front, top, sides. So front is going to be 4 by 20. I'm going to times it by 2 because there's front and back. Side, or sorry, top will be 20 by 8 or 8 by 20, doesn't matter. Times by 2, and then my sides are 8 by 4. Times it by 2. Remember, I'm always doing the times 2 because front and back, top and bottom, sides are both the same. Fire it in, get your answers, add them up. And that's how you ensure you get your marks for it. Alright, the only thing that can go wrong from here on in is that you put something wrong in your calculator. So I would always do each multiplication, then just do a big addition. Okay. And again, you might want to pause here. Have a wee go at these. So I'm asking for, and I would round where possible to 1 decimal place. Okay, so for each of these, the answers are next. Okay, for each of these, I want the volume and the surface area of each shape. Okay, so it's basically both types of questions we've looked at for cuboid. Okay, and make sure you can get these answers. If you're alright with the first 3 or 4, you're going to be alright with the next. Okay, all that changes is the numbers, the method doesn't change. Okay, so the answers are there, give them a wee check, make sure you can get the answers with showing all the working. Okay. So maybe what I pause here, have a go doing that before you move on. Okay, so the video is just going to keep going. Last but not least, cylinder. So again, the first bit of cylinder is fairly straightforward. It is calculating the volume, and you are given, I know you're working at home, and if we do an assessment with you, you're going to have access to these equations, but in class, and in your assessment, if you were in class, you would have volume pi r squared h. You're going to get given that. Okay, pi is your button in your calculator. Radius is coming from the circle bit again. The height should be obvious that the height of that cylinder is 17. Now, we said before, when we're dealing with circle, the radius was, if I was to draw a circle, the radius is from the centre out. Doesn't matter which direction it's in. Okay? Now, if you look at the top, if you were to look down on it, it's a circle at the top. We are given the radius here, so we don't need to worry about halving things or doubling things. So the radius is 6 squared. If you were to fire that in your calculator, you get pi times 6 squared times 17. You get 1922.65. So I'll just round it to 7. So 19.7, and it's volume, so centimeters cubed. Okay, volume's dead easy. The only thing you need to watch for volume, if I go back, is watch that you don't get given, for instance, a diameter. So say you got given, say that was 18. The equation, even though you're given a diameter, the equation calls for the radius. So if you're given a diameter, you remember you need to half it. You would need to, if it was this 18, you would have to go 18 divided by 2, which is 9. Okay? So, and again, there's questions at the end, and there's a mixture of radiuses or radii and diameters. Okay? So just watch what the diagram gives you. Next wee bit, this thing, I know it's the same question, but it's asking for the curved surface area. Now this is a wee dodgy one, okay? The curved surface area. So if you imagine, right, we looked at surface area before for the cuboid. So you imagine a shoebox, you've got your lid, bottom, sides are the same, front and back are the same, right? Fairly straightforward. Here it's a bit tricky. When we talk about the curved surface area, all we're talking about is the walls of a cylinder. So if you imagine, if you were to take a Pringles box, right, and cut the top and the bottom off, cut down the side, and roll it out flat. If you imagine what that would look like, alright? So if you were to get this, if you were to cut down and then roll it out, you would be left with a rectangle. Okay? I'm not talking, we're ignoring, we've cut off the top and the bottom, we're not bothered about the lids. Okay? We're just talking about the curved surface area. The curved surface area of a cylinder is just looking at the walls. So the vertical walls, if you like. Alright? Now, this 17, the height 17 stays the same. That doesn't change. This length here is the important bit when it comes to curved surface area. Alright, so this is kind of combining circles and rectangles, and you'll see why. So this is a rectangle. We know the area of a rectangle is L times B. That length there is the length, the distance around the top unfolded. And that distance around the top, we said before, in circle terms, is the circumference. And we know, if you check back, circumference is pi d. Okay, so the circumference for a circle is pi d. This length here is the circumference. So the equation you've got, and you don't need to prove this, you can just remember this. Okay, this is the trick. This is arguably the hardest thing to do, I think, out the whole outcome to the curved surface area, and it is difficult. The curved surface area is the curved surface area equation is pi d h, because it is the rectangle here, right, which is this length times this length in cylindrical terms is the height, and this length here was the circumference, because it was this cut here and unfolded, so that's not changed. So all you would have to do is do pi times the diameter times the height, and we know the height is 17. Now the diameter, kind of what I touched on before, this is the radius, this 6 is the radius, it's half of it, so we need to double it, times 12. Plug that in your calculator, pi times 12 times 17. This gives you 640.9, 640.9, and it's just centimetres squared because it's an area this time. Okay, so this curved surface area bit, it is tricky. However, if you remember this equation, right, it's fairly straightforward. Okay, so I'll go through this one as well. So curved surface area, so CSA, is pi dh. Pi is the button in your calculator, diameters and the d and the h are from this. H is 22, that's an easy one to spot. 7, we are given the total width of the cylinder, so that is the diameter, so it's just pi times 7 times 22. Pi times 7 times 22. Okay, 483.8. So 483.8 centimetres squared, because remember it's an area this time. Okay, it's an area this time. Alright, so that is everything in outcome 2. Okay, so the 3 sections, if you like, if you want to break it down, if you're sitting working through it, excuse me, the 3 sections, if I go back to the very start, okay, and just to finish, right, I've got for each cylinder below, calculate the volume and the total curved surface area. Okay, so remember it's a curved surface area, so it's round, it's not including the top and the bottom. If you were to calculate the surface area of a cylinder, you would include the top and the bottom, but we're not. I would also go round to 1 decimal place. That's what I've done in the answers, okay? So round it to 1 decimal place, okay? And again, there's the answers there. So just make sure you can get to that. Take your time with it all. I know there's a lot in the video, so if I go right back to the start, so the 3 sections in this that we want to focus on, and in fact actually I've changed this, what you tend to find some people do is 2 pi RH, but I'm going to go pi dH, okay? So save that. So I will upload the video. I'll upload a full work solutions for the notes, so the ones that I've missed out will be included, so like the first perimeter or the second perimeter in area 1, the final circle bit when it comes to area, give those a go yourself. I'll upload more worksheets, okay? Break it down if you're sitting with this video open, okay, or if you've got to the end of it and you're still a bit confused, just break it. There's 3 sections, there's perimeter and area of 2D shapes, there's volume and surface area of cubes and cuboids, there is also volume and curved surface area of cylinders. So see it as 3 separate sections that you can break down, okay? Right, best luck. Anything you need, please get in touch. I will upload if you're totally fine with this, if you get everything, if you've done it in school, have a go at doing the outcome 2 practice assessment from the back of your workbook. It will be on page like 100 and something, so the very last page of those craft booklets was the practice for the last outcome, that outcome 5 with the substitution of the numbers into your equations. Just flick back and find it. You'll see there's three kind of categories. There's perimeter and area, there's the cuboid, and then there's the cylinder. Okay, and I'll put up a full work solution and video for that as well. Alright, best luck. If you need anything, get in touch. Okay.